Good morning, students. The topic for today's lecture is light transmission in optical fiber. As we know that the information signal is converted in the form of light using LED source or laser source. This light propagates along the fiber axis. There is a principle of light transmission in optical fiber. The fiber optics deals with transmission of light energy through transparent fibers. The optical fiber guides the light, which depends upon the nature of the light and the structure of the optical fiber. We know that light wave is a form of energy having its speed, which is equal to 3 into 10 to power 8 meter per second, and it is moved by a wave motion. In fiber optics, wave motion is the movement of light energy through optical fiber, means how a light with its different modes travels along the optical fiber axis. Optical fiber has an inner portion which is known as the core and the outer portion which is known as the clad. The core and the clad in optical fiber, they are differentiated in terms of refractive index. The core refractive index is more as compared to the clad refractive index. Due to this, the core and clad interface forces the light transmission to be within the core structure of the optical fiber. The optical fiber, as I already told you, that the inner portion is known as the core and the outer portion is known as the clad. The cladding portion supports the core. Then outer buffering is there, which supports the ultimately core and the clad structure of the fiber. The light basically is inserted into the core structure with specialized techniques, and due to core clad interface, the wave optics allows the light to travel within the core portion along the fiber axis. The core is made up of a dielectric material and it is surrounded by cladding, but the difference is that the core refractive index is more as compared to the clad refractive index. Fiber media. Optical fiber uses light to send information through optical medium. It uses the principle of total internal reflection. The light which is generated by laser source and the LED source is first modulated in accordance with the information signal, means whatever the information we want to transmit, if we want to send it to a longer distance, then first it is modulated using a carrier. The modulated light with the help of laser and the LED sources are transmitted through the optical fiber using core clad interface. Recently we have studied about a refractive index, that the core has a one type of a higher refractive index and the clad has a lower refractive index. But first of all, what do you mean by refractive index? The refractive index is the ratio of speed of light in air to the speed of light in medium. We know that the speed of light in air is denoted by a variable c and is having value is equal to 3 into 10 to the power 8 meter per second in free space. Then if we transmit the same light in a particular medium, it has a different velocity. So how much is the speed of light in air to the how much is the speed of light in medium? This ratio c by v, it decides the refractive index value. For different materials, the value of refractive index is different. For vacuum, it is 1. For air, it is also equal to 1. For water, the value of refractive index is 1.33. For glass, the value of refractive index varies from 1.5 to 1.9 depending upon the constituents of the glass fibers. Although the basic constituent for fiber structure is silica, but during the fabrication process we add some other materials along with the silica, which changes the refractive index of the glass fiber. So refractive index is the amount of refraction or bending that occurs at the interface of two materials of different density. Refractive index is also known as index of refraction, and it is denoted by a variable n. So n is equal to c by v, where c is speed of light in air and v is speed of light in material. These are the values. I told you that in air it is 1, for water it is 1.3, for glass it varies from 1.5 to 1.9. So this refractive index is very important to decide the path of the optical signal along the core clad interface. So this is a table for refractive index of some of the materials. As you can see, it is different for different materials. Again, I will show you the formula. Refractive index is denoted by value n, and it is equal to ratio of c by v, where c is 3 into 10 to the power 8 meter per second divided by velocity in a particular material. So this n is a refractive index, and these are the values of n. Now, when the light travels along the fiber axis, it first strikes the core clad interface. Here, this is the incidence light I. it strikes the core surface. This is core. But this surface is also attached with clad. So clad has a refractive index N2 and core has a refractive index N1 with value of N2 is less than N1. It means that the refractive index of the core is more as compared to the clad refractive index. So this is a normal line, perpendicular line. When light strikes the core clad interface at particular angle with respect to the normal, this line is known as the incidence angle. So incidence angle, at a particular incidence angle, some of the light of the incident ray is traveled back to the core portion, as you can see by blue light, and this is known as the reflected light. However, some portion of the incidence ray goes into the cladding portion, and as shown by green light, it becomes a refracted ray. So refraction occurs when light goes inside the material having different refractive index. So slightly bending occurs. So as shown, the incident light may be converted into reflected light or may be converted into a refracted light. Okay, but this only happens at the core clad material boundary. So light always travels in a straight line. We know that. There are different laws of reflection and laws of refraction. Based upon this, the incident light is reflected back into the core portion or reflected out of the core portion into the cladding portion. This law of reflection is reflection from a mirror or at the boundary between two media of different refractive index. The angle of reflection equals to the angle of incidence. It means whatever is the angle of incidence, the same is the angle of reflection. This is the law of reflection of optical waves. This is very important. The angle at which the light strikes a surface of the mirror with respect to the normal is called as the angle of incidence. Okay, the angle of incidence light determines whether the incident light will be reflected back into the core or will be refracted out of the core. But if the angle of incidence is equal to angle of reflection, then the rule is called as the law of reflection. There is another law which is known as the Snell's law. This law is basically the law of refraction. Snell's law states how light ray reacts when it will meet the interface of two boundary two materials boundary having different index of refraction. It means when a light strikes core clad interface. We know that core has a higher refractive index N1, clad has a lower refractive index N2, and the layer at which this core and clad interface is there. This interface is important to decide the different index of refraction. So when the light ray encounters a boundary which separates two different refractive index, the some portion of the light is reflected back into the first medium, that is core, and the other portion is refracted, or we can say bent into the second medium. Okay, then the Snell's law is given by a formula n1 sine theta 1 is equal to n2 sine theta 2, means theta 1 is, or theta I is incidence, Ni is refractive index of the first material, that is core. So n1 sine theta 1 is equal to n2 sine theta 2. This law is called as the Snell's law of refraction. It is very important law. Then another parameter is critical angle. Basically, this critical angle decides whether the incidence light will be converted into a reflected light or a refracted light. So this is a parameter. This is very crucial to find out. But it can be found out with a formula which depends upon the refractive index of core and the clad. So what is critical angle? Critical angle is basically the angle of incidence that causes the refracted ray to travel along the interface between the two medias. So critical angle is given by formula theta c is equal to sine inverse of n2 by n1. n2 is refractive index of the clad and n1 is the refractive index of the core. So how critical angle will decide, it will be shown in the coming slides. First, Snell's law. Now, when a ray is incidence on the interface between two dielectrics of different refractive indexes, reflection and refraction occurs. We will repeat this point again and again. Again, I will show that the light is, this green is incidence light which we want to travel along the fiber. Some portion of this is reflected back into the same medium, means of refractive index n1, whereas some portion of this light is refracted into another medium, that is N2. But how much is reflected back into the core and how much is refracted into the clad is decided by the critical angle, that is critical angle. But the law of refraction, which decides the how much is the light is refracted into the cladding portion, is decided by a formula n1 sin theta 1 is equal to n2 sin theta 2. Okay, from this law we can decide the value of angle of incidence. In the last slides, I told you about the critical angle. When critical angle has been decided, this angle is compared with the angle of incidence light. It means at angle the angle at which the light is inserted into the fiber. The first portion is number 1. If the incidence light is at an angle which is less than critical angle of refraction, the light will automatically goes into the cladding portion, which is less dense medium. So more dense is having refractive index N1 and less dense has refractive index N2. So when angle is less than critical angle of refraction, the light will go into the cladding portion and it becomes refracted ray. It becomes refracted ray. Although this refracted ray is a part of the communication, but it is less useful because our prime concern is for the light wave that is within the core portion, means that is within the more dense medium. Now the second case, if we see that the angle of the incidence is equal to, is the same as the critical angle that we have evaluated, if both are same, means if angle of incidence is equal to critical angle, then what will happen? The incidence light will travel along the fiber axis at the core clad interface. So the light will go straight. Now the third case. In third case, if angle of incidence is made greater than the critical angle of incidence, all the light will be reflected back. I will repeat, reflected back. Where? Into the same medium from where it comes. It means the light is coming from the core and it will be reflected back into the core, and it goes on. And this reflected light carries the important information, and it is traveling along the core by striking at again and again at the core clad interface. So important thing is, if angle is equal to the critical angle, then the light will go straight. If angle is greater than critical angle, the light will be reflected back into the core and will be important for communication. But if angle is less than critical angle, the light will be refracted out of the fiber and it will be less important to us. So, at angle of incidence greater than the critical angle, the light is totally reflected back into the material of higher refractive index, that is core, and this is known as the total internal reflection. Okay, again you can see we have critical angle theta c and we have incidence the light at angle theta 1, which is greater than theta c. It strikes the core clad interface at this point. Then, because the light incidence light is having an angle greater than theta c critical angle, so the incidence light will be converted into total internal reflected light. Here is an example. Let us suppose we have a fiber having core of refractive index 1.44 and 1 is equal to 1.44. The same fiber has a clad of 1, so N2 is equal to N1. So critical angle can be evaluated from the formula sine inverse of N2 by N1. So it is sine inverse of 1 divided by 1.44. So the critical angle comes out to 44 degree. So if we want the total internal reflection or angle of incidence with respect to the normal, it should be greater than 44. It should be greater than 44. Only then total internal reflection will be there. At an angle of 44, the light will go straight. But if angle is less than 44, the light will go into the cladding portion and it becomes the refracted light. So when light strikes an object, some of the waves are absorbed by the object, some are reflected by it, some might pass into it. So when light strikes an object, three things are there. One is reflection, another is transmission, and third one is absorption. Property of light. What happens to the light when it strikes the material? It depends upon the nature of the material or the type of the material or the refractive index of the material. There are three types of material. One is transparent, another is translucent, and the third category is opaque. The transparent means a clear material. Example, glass. So what happens? When light falls on the glass, it transmits the light. Another, translucent material, which scatters the transmitted light. After the light goes into the material. And the third one is opaque. Opaque means the material from which we cannot see. such materials absorbs and reflect the light. Such materials absorbs and reflect the light. So first is transparent material, example glass. Okay, these material travels or transmits the light falling upon them. We can easily see that we can view the images of the objects from the glass. So such materials are transparent materials, and it allows nearly all of the light that strikes them to pass through. Second is translucent materials, or we can say see-through materials. The material through which some light ray can pass, but the object cannot see clearly because the rays are diffused. Objects behind these materials are visible but are not clear. Example of frost glass or a piece of oiled paper are the examples of translucent materials. The third category is opaque, means through which we cannot see. These materials are unable to transmit light waves falling upon them, and they are called as opaque material. Example, walls of the room. So, a particular incident ray, if we want it to be converted into reflected light, the reflected light are those waves that are neither transmitted nor absorbed but are reflected from the surface of the medium. So, when light wave approaches a reflected surface such as mirror, the wave that strikes the surface is called as incident wave, as shown by the red line. It strikes the boundary at a point and it bounces back, as shown by blue light. The blue light is called as the reflected light, and the angle is known as the angle of reflection, that is in between normal and the angle of reflection. The amount of incident energy that is reflected from the surface, that how much will be coming out after it strikes the interface, it depends on number one, the nature of the surface, and the angle at which the wave strikes the surface. Example, if the nature of the surface is rough, very less light will be reflected out. But if it is smooth, more light will be reflected out. The second parameter is the angle. We have seen already that if angle is less than the critical angle, what will happen? I will again show you the slides. If angle is less than the critical angle, the light will go into the cladding, as shown by number 1. If it is equal to the critical angle, the light will go straight. But if angle is greater than the critical angle, the light will be reflected back into the medium, and it becomes the reflected light. What happens when a light strikes a material which is not transparent, example frost glass, having different refractive index, when a light wave passes from one medium to another medium having different velocity of propagation, a change in the direction of the wave will occur. This change of direction as the wave enters the second medium is known as refraction. In normal life, you can see, put a spoon on a transparent cup filled with water. The spoon will not be appearing straight, but rather it will be seen as a bented portion. How this bent appears? The spoon is straight. We can take another example. Put a pen into the water. The pen will not appear same. Slight change in the shape of the material will happen. This is due to the refraction process. Then there is a diffusion. When light wave is reflected from a piece of white paper, the reflected beam is scattered or diffused. Since the surface of the paper is not smooth, the reflected light is broken into many light beams and it is reflected in all directions. So the upper portion, which has a clear surface, the incident light will be converted into the reflected light with a clear cut angles and it will go straight. But if the surface is not smooth, the incident light will be broken into many light beams and all the reflected beams will be traveling in multiple directions. Some may go forward, some may come back in the back direction. Another important parameter is absorption. When light is fallen on a dark piece of paper or black paper, almost all of the light will be absorbed and very few light will be reflected from the paper. If the surface upon which the light beam fall is perfect black, then there will be no reflection. The light is totally absorbed. But if it is slight dark, some of the light may be reflected back and some may be absorbed. And this is called as the process of absorption. Then another important part is called as acceptance angle. Acceptance angle means the angle of an optical fiber. We can say it is the maximum angle of a ray hitting the fiber core, which allows the incident light to be guided by the core. What is the meaning of this? The acceptance angle is also called as numerical aperture. It decides at which angle the light should be inserted into the core from laser or LED. Okay, The acceptance angle of an optical fiber is defined as the maximum angle of a ray hitting the core, which allows the incident light to be guided by the core. And numerical aperture is given by formula Na is equal to n1 square minus n2 square under root, where n1 is refractive index of the core and n2 is refractive index of the clad. Okay, so numerical aperture will define the acceptance cone. So this is the acceptance cone, that if light coming out from the laser or LED is within this portion, then all the light will be inserted into the core portion. But any angle greater than this cone angle, it will be not properly going within the core, and the light will be wasted out. Thank you. Thanks a lot. If you have any doubt, you can contact me at my email address, that is principalsspc@gmail.com. Thank you.